Hi, I'm Kyle Keane.
And I'm Michael Kaminsky.
And our presentation is about a suite of tools that we use at MIT to teach computational thinking and programming. So I'm going to talk about a suite of tools that we are building and using at MIT to create curriculum like homework assignments. Are you trying to signal me?
No, sorry. No.
Oh, all right. I was like... so a suite of tools that we're building and using at MIT to make homework assignments and run live classes, all involving kind of Mathematica and coding. And mostly the second half of the talk will be about the data analysis that we're doing. So every assignment that we give to a student, as well as every class, we collect a lot of data about keystrokes and code evaluations. And so we were trying to extract some useful information, like how long did students take on this assignment, what were common syntax errors, and things like that. My name is Kyle Keane.
And I'm Michael Kaminsky.
There you go. And Professor Craig Carter is our benefactor, I guess is a good word. So if at any point you zone out, the important thing to remember is you can go to CodeSeal.org and you can download this. So this is an application that adds on to Mathematica the ability to write homework assignments. So if you want to go download the application, then you can build your own homework assignments using the tools that we have created. Yes. Oh wait, it's projecting, sorry. Let's go to normal people colors. Yes, so there's some faces of Craig Carter and myself. And we, at this point, have about 10 educators who are beta testing all the tools in their classes. So it is working and it is being used, which is exciting. We have some UX designers who are volunteering to help make things better, and a lot of students who have found it interesting and are willing to write content for calculus and physics and go outside of material science, which is where we started. And then we have some educational researchers who are helping us to define meaningful questions that we can extract from the data that we collected. So there's 3 tools. Oh, all right, that fits better. 3 tools, and they're named so that I can keep them straight in my mind: Colab, Coset, and Codat. Colab has to do with like you're inside of a collaborative learning environment. So we run live coding classes. Coset, it comes from at MIT, they call their homeworks problem sets, and then they shorten it to P-set. And we want it to be a little bit more collaborative coding experience, so it's a co-set. And Codat is just fun to say for me, and it's about the data that we collect and analyze. So it's like a Fitbit for learning. So one long slide on the Colab, how we run live classes. The idea is fairly simple. I'm programming in Mathematica and my students are programming in Mathematica. I start a Colab which gives me a link where my students can download a notebook. And then I tell my students, hey, try to do this thing, because I want them to actually code inside of the classroom. So I tell them, I'll zoom in, produce a nice visual. Students do some actual work. And they make edits, and I collect data about every edit that they're making on their code every time they do Shift-Enter in Mathematica. I can then pull in all of the responses, but this is a bit of an overwhelming thing. It's fairly useful. I can kind of go through and scroll and look at what everybody submitted. So this is helpful because I can go make edits and talk about people's code. But the other thing that we're adding on top of that is one more layer, which is every piece of code can be represented as a tree, and so you can look at the distance between 2 trees of code. So everybody submits a piece of code to an answer, and then I, as an instructor, can come and talk about a particular student's code. So I can say, these people are trying to visualize some data or visualize a curve. So a bunch of students used list plot, some use parametric, and some use plot, and I use cluster classify to kind of find the graph communities and figure out what students have submitted. And then I have analytics about for this type of challenge, I can figure out what types of code were useful. Are these really big pieces of code that were required, or are they short? And students can figure out if they're writing code that's kind of a complexity that's equivalent to their peers. And we get some nice personal analytics. So it's like a Fitbit report. So you can say, you submitted this piece of code that was this big, and you're about at the level of all the other students. And not to say that code complexity has to do with being better or worse, but it's at least some way to do self-reflection. So, I don't know what's happening with that.
Just scroll over.
Oh, all right. That was like an animation effect, a slide over. So the CodeSeal, the homework system, is mildly complicated, and I really like clip art. And so I made something out of clip art to describe it. So a teacher writes some content. They make a Mathematica notebook. That's been happening for the last 25, 30 years. What you do with the system is you then click a button, and it creates a more interactive version that the student is going to interact with and do their work inside of, and they're going to send that back to you. So yesterday we had a workshop, and everybody really saw what that process looked like. I will briefly show that the system, what I mean by authoring is there's a palette, and it comes with some templates if you want to view an example template. All right. For instance, here is a giant notebook that we use to teach students how to program. You can put metadata about who has made edits to the file, and then you make a Mathematica notebook, and you edit it using this palette, or using keyboard shortcuts, or using this, or using file, or using format style. So there's like 1,000 ways to make a notebook. And then you convert it by clicking a button, and that takes all of that work, all of that notebook, and converts it into something which is much more interactive and involves some scaffolding. So it forces students to have tried a problem before they get to see a solution. And I know it's very mesmerizing. It's my favorite part. You get to just sit and watch Mathematica do a bunch of stuff. It makes multiple choice questions. It adds points. It makes some things optional. I should have done maybe a smaller file. It'll get there. Yeah, I hope it'll get there.
Progress file for that one?
No, not unfortunately, not yet.
Yeah, move the window to the left so you can see the scroll bar.
It does some level of jumping. It kind of goes through 3 iterations of the file. It's getting close, so it's shutting down all of the sections right now and packing solutions into the file with encryption. And now it'll take one moment to add. So it has to activate the little data collection screen. There we go, and it tells you to save it. So I'm not going to save it. All right. I didn't know that was a punchline. All right, fair enough. So this is the file that you then send to students. And this file lets them either link it to their account, their Wolfram Cloud account, which lets them pull down all the data that's collected about them. I store it with keyed salted hash encryption on the Wolfram Cloud, or they can anonymously give us data so that we can study how many key presses they had and when they were doing code and at what part of the file, or they can totally opt out. So for this, I will totally opt out. It tells the student to save it. I will get rid of this palette because now I'm, front end, there we go. All right, so now I'm in student mode, and I've opened a file that the professor has sent me, and I've chosen not to donate my data. And I'm going to go through, and there's sections that I kind of read, chapters that have lots of stuff for me to read. Let's see, there's probably a problem somewhere down in here. There you go. So more things. There's color coding. If you want to change and have a less colorful version, you can do that. Problems are things where we tell them to do work. They have to go to a specific part in the notebook, and after you show them that, it's not very confusing. They give feedback. So I'm a big fan of metacognition, so forcing them to reflect on, did this make sense, and what part of it did not make sense. So you can tell them to let me know this problem wasn't asking me something that was clear, or this problem was, too simple. So by submitting work, it kind of locks their work and grays it out, and then gives them an editable version if they want to resubmit. And by doing work, they can then view a solution. So I will be adding in the coming months the ability to kind of not release this instantly, but to release after a certain date. Right now, if they submit work, they get to see the solution. We're not too worried about catching cheaters. Not in that way, at least. And then this gives them a step-by-step thing where they get to see a chunk of code and text or whatever I want to include in my solution. And then they have to tell me whether that step made sense or if it was not verbose enough. And they get to view the next step. And then at the very end, they have to give some reflection. And so far, students have been quite respectful of this system, and they give meaningful feedback. We were able to find some typos inside of the solutions because there was points where a bunch of students said this doesn't make sense. And we went and looked, and it didn't make sense. So that was very helpful, because otherwise it's an incredible task to try to edit one of these giant notebooks and figure out where errors occur. And yeah, so that's an overview of kind of the workflow inside of the notebook. There's also a slideshow view of this notebook, but I won't go into too many more details about that. So that is the authoring system. And
if you log on with your Harvard ID and not your MIT ID, does it make the questions easier?
I abstain. Yes, so that was also, I kind of showed the student workflow as well. I will briefly, does this count down to the time when I need to stop talking, or the time? Okay. Oh, all right, yeah, we have, okay, that's the time when I should stop. 5 minutes? Oh, okay, all right, so I'm gonna stop my, I'm gonna skip my soapbox and say, you all know if you have, so this is what we want students to give as an answer. I don't care if a student can get to the answer 2. I want them to actually construct a meaningful, thoughtful, using math, using code response. And I don't think that that is going to be automated anytime soon. But I wish people luck if they want to. So next I will hand over to Michael to talk about the data analysis portion. So all of these homework assignments, and during class we collect every piece of code that was written and run, every key press, every notebook that's open inside of Mathematica at any moment, how many documentation files are open. So he will talk about our attempts to extract meaningful information. There's a long-term future possible with computer-aided grading, where you say that piece of code looks like this other set of pieces of code that solved this problem. We are not there yet. I think right now in the short term, what you can give is data-driven insight and reflection. So I spent 30 hours on this homework assignment. Everyone else spent 10. Maybe I should adjust my time management skills. I think that that's a very achievable insight that we can do kind of immediately. Yeah, so we'll start with one student's homework submission and what we can look at and study about that particular student. And I'll let Michael talk about that.
All right, I'm gonna blow through these in like 5 minutes.
You can take 10, it's all right.
Why don't I leave some time for questions? Okay, 9. So this is like one of the examples of the graphs that we might create. So like just like when you're writing an essay or you're going through an English class, as the class progresses, you want to use more and more words and expand your vocabulary. And that's kind of the goal of an assignment that you might do in Mathematica. You learn more symbols, more functions, and you kind of expand like how complex your code is. So this is just keeping a running tally of kind of like the number of symbols used by a student over the course of an assignment. You can see it generally trends upwards, which is what you kind of want to see. There's some more sophisticated ways to measure this rather than just like the pure number of symbols used. So kind of representing, okay, I'll zoom out a little bit.
Pinch zoom
All right, there we go. So kind of representing each of the evaluations as a tree. You can look at the leaves and the nodes of the tree and use that as a gauge of code complexity. And so these are several different measures of that, and then the average value, which is the orange line you see there, or like the orange squiggle line, and just the average trend. So again, you can see that in this example, the code complexity is generally going up, which is what you want to see. Yeah, so this is just to show like, in addition, students run their own code, but they also run the code submitted by the professors. So it's important to be able to distinguish between those because like of all the evaluations, a lot of them are things in the actual assignment, things like that are examples that the professors provide, but the actual solutions are only a small portion of that. So it's important to be able to keep track of those and to see what kind of code the students are evaluating. And so since you can represent the code as a tree, and you can analyze this and find the distance between those and kind of see the way that a student's code might evolve over the span of an assignment, over the span of a semester, over the span of a course in general. Yes, these are just some general statistics about like kind of the first major test that we did with the like following kind of graphs. So this is a pretty simple graph. It's just generally showing when this specific student was active. Apparently he did not feel like spending 5 hours straight coding nonstop in Mathematica. But you can see just kind of, it's a nice little graph to show just when someone was active. You might see some of them bunched up towards the due date. And it's interesting just to see the kind of distribution. And just good for a professor to see, they assign it too early, too late. When do people start working on this? So this is some more examples of activity. So the top one, that's just the total time worked. It shows the mean and median for a class, and the highlighted bar is just kind of where the specific student fell in that distribution. So the basically fell in the 0 to 1 hours of just like actual coding. So not like staring at it, doing research, but like actually typing. So you can see kind of like, and it's not necessarily a measure of like how good they were, but it's an interesting statistic to see. And this next one is a time breakdown of how long people spent on, or like this one student, or actually this is the whole class, spent on different problems. So that's along the horizontal axis. And the amount of hours worked, and each of the bars are split up by the sections within the problem. So again, a professor might say, oh, this problem took longer than I expected for the class as a whole, or and be able to adjust the future assignments accordingly. All right.
The front end hang.
Yeah, a little bit. I don't know. Oh, it's alive. Okay, this beautiful jumble of text. This is what happens when you take basically all the code that each of the 29 students wrote, and you just represent it as a word cloud. And looking at this, it's like a professor looking at this might be able to get a very like intuitive sense, like pretty quickly, about what kinds of symbols people use, or like students in general use. You might not want to spend the time to individually pick out like, I don't know, this one specific symbol this one specific student used, but you can kind of see general trends. People like to use pi, they like to use sine a lot. Just pretty like basic stuff, but again, it's interesting to see and can be useful for professor or the student in general. And this is just the same thing represented as the class as a whole as opposed to individual students. Code similarity, I think we talked about that a little bit. And another important thing is the errors. So what people, where the errors are kind of shows where people had trouble. So representing this as like the syntax errors as opposed to kernel errors, both as a table and as a word cloud can kind of give you a general idea of what people are having trouble with and can show a professor what they need to focus on. And this is one specific student, and it's a timeline plot of, again, where they made errors. So there's syntax errors, kernel errors, and the different colors represent the problem they were working on when they had those issues. Rest in peace, notebook. Okay, so one of the last things is, this is basically, again, word clouds of what documentation students visited. And this is I personally think this is pretty cool because you can see not only what people had trouble in this area, but like what they took the steps to kind of figure out how to use certain things. You can see people who maybe they had a lot of errors, but they didn't visit the documentation a lot. It's like, maybe you should do that, and maybe you'll have fewer errors. And people who visited all these different documentations are really, like one person might have visited log a lot. They just couldn't remember how do you use log. Yeah, so you can see some people, they didn't visit the documentation at all. Some visited.
One word cloud per student?
Yeah, one word cloud per student. So again,
And it represents the time spent in that file?
the number of times they visited.
Number of times they visited.
Yeah.
Are those empty ones people that actually never went to the
That's either people who didn't go there, or we're having some issues with like the data collection for several of them, so just didn't have that data. So again, pretty fun graph. Okay, I have like, and this is basically the same thing, but for one student, what documentation they visited. They like to visit plot a lot in log. It's good stuff. So if 1.5 minutes left. So 1.5 minutes of questions.
Are you going to put your slideshow up on the conference?
Yeah, it'll go on to Pathable.
Okay, good.
Yeah.
Second question is, I downloaded CodeSeal with 11.3 and it's fine and everything. Now, if I upgrade to 11.4.12, will I have to re-download it, or will it automatically put you under PAL?
Yeah, it automatically updates itself. Every time you try to use it, it checks the cloud to see if it's out of date, and it lets you know you should update.
No, I mean, if I upgrade.
Oh, if you update, I don't know if you install a new version. You probably have to go reinstall it. Yeah.
Okay, I installed the new version and it seemed to be all right.
Oh, okay. Will it remember which?
Well, when I'm working on 11.3, let's say, and I do all this stuff, then upgrade to 12 whenever it comes out, and I re-download it if I have to. Will it then save all will my stuff be there?
Your stuff is just files, yeah. So they're just notebooks.
They'll be fine.
Yeah, they'll be perfectly fine and compatible to convert again.
Thank you.
Yep.
Yeah, two quick questions. Can I run a CodeSeal class in the cloud using Wolfram Cloud, or is that now desktop?
Right now, it's all desktop based.
Okay.
Yeah.
Second question, if I haven't visited any docs, I have the minimum number of keystrokes, and I am the least number of hours committed to every problem, but I'm always getting them right. Am I a cheater?
No, if you have copied code that showed up in other students' solutions or in the solutions that were given, yeah. So plagiarism detection is what we would say. No, there are extremely bright students in the class who have programmed before. Yeah, no. So and it never kind of accuses a student of being a cheater, but it does throw a mild flag, or we're kind of building out code right now to throw a mild flag that says something fishy, you might want to talk to that. So we believe in kind of helping a human manage a classroom better. Yeah.
Really quick.
I have one last question. What's the turnover? How quick can you give a professor data? Like, can this be, is the first assignment, how quickly can you analyze it and give the professor input? Can he actually change his class during the semester real time?
Yes, it's as soon as they request their aggregated data, they will get all of the aggregated data. So it's constantly streaming the data to the cloud. So a student mid-assignment can pull all of their own data and analyze it. A professor mid-assignment, we don't know if we'll let them, but they could, in theory, pull all of their data and analyze it. I think that we should wait till the very end, but maybe I won't try to manage that thing. So yeah, it's sitting in the cloud at any moment, and when you pull it down, we're giving notebooks that analyze it and build out the report at any moment. Yeah.
All right.